We can take more complicated expressions and we can evaluate them using a truth table. So we're going to try this expression here. Now notice this expression is going to use all three variables, P, Q, and R, statement variables, so to speak. When we construct this table, notice that we have P, Q, and R. So let's see, we have to get all our possibilities. We could have the first two true and R is true, or the first two true and R is false. Those are those possibilities. Now we could still have P true and then Q false, and R is true, or P is true, Q is false, and R is false. That's half of the possibilities. That's the first four of them. Now notice the last column, this is R, is going true, false, true, false. It's going to go true, false all the way down. But now we have to start thinking, suppose P is false, and I'm actually going to go back up to the beginning here and say Q is true, R is true. Or P is false, and I'm taking the second one here, Q is true, R is false. Or P is false, and now I have to consider if Q is false, R could be true, or we could have false, false, followed by false. Those are all the possibilities. Now let's look at our statement. We need to consider Q or R, so we need a column for this. That's what we have next. Looking ahead, once we have all those truth values, we'll have our final column, P and the quantity Q or R. So for Q or R, I'm looking at the Q column and the R column. Now Q or R, remember, this is true unless they're both false. So this is true, true. As long as one of them is true, they're both true. Oh, here they're both false. So this is false. This one's true, this one's true, this one's true, and this last one is false. So that's my Q or R. Now I'm looking at P, which is this column, or Q or R, which is this column. So these are the two columns I'm comparing. And the way I'm operating is with AND. So AND is only true if they're both true. Well, in the first case, they are both true. In the second case, they're both true. Gee, in the third case, they're both true. But now, one of them is false. And I see all the way through to the end here, this P is false. So as long as one of them is false, the conjunction is false. So this is my truth table all filled out. Now we're going to extend it and actually look at another expression. So we're going to construct a truth table for this expression, and I've kept our original result. This is the result we just got a moment ago. I'm going to keep the same table, but I'm going to extend it now. So I'm going to need a P and Q, so let me put this here. These are sort of the insides. P and R, that's the inside that I need. Those are what's in the parentheses. And then at the end, I'm going to have my P and Q in parentheses, or P and R in parentheses. So those are my headings. Right now I'm looking at P and Q, so I'm going to be looking at the P column and the Q column. And remember, it's true only if they're both true. So let's see, this one is true and this one is true. As soon as I see one of them is false, my result is false. And all the way through here, all these results are false. Now I'm doing P and R, so I'm looking at the P column and the R column. This is very important that you're picking up the correct column. Now let's see, if they're both true, the conjunction is true. Here R is false, so this one is false. Now here they are both true, so this one is true. Now we have false, false, and all the rest are false. And I know that because one of them was false. This is P and R. One of them was false all the way down here. Now we move to our last column, and this is using P and Q, P and R. So the two columns I'm using are the previous two columns. I'm using the connective, you might call this, or the operator is OR. So remember, with OR, it's going to be true unless they're both false. So this one is true, this one is true, this one is true. Here they are both false, so this one is false. They're both false, so this one is false, and this one is false. Actually, all the way through down here, both of them are false. All right, and now I've found the truth values for our second expression. And now take a look at the two compound statements which we evaluated a very interesting thing happened. These two columns of truth values are actually identical. And if that happens, that means these two expressions are really equivalent expressions. They're really the same thing written in a different way. And we're going to talk about this idea of equivalence, because that's one more important part of symbolic logic, is that some expressions are equivalent to each other. And here's our definition. Statements are logically equivalent if and only if they have identical truth values in all possible cases. Let's go back for a moment. Do you see how these two columns were completely identical? Therefore, these two expressions are logically equivalent. And this is the symbol that we use to denote equivalence. A couple more definitions. A tautology is a statement which is always true. It doesn't matter what is true about the component statements. It's just always true. As opposed to a contradiction, which is always false, regardless of the truth values of its component statements. A quick example of each. In this first case, let's look at P and not P. To make the truth table, I have P set up already. Let's put in not P. Remember, the negation of P has the opposite truth value. Now I'm doing the AND for these two columns. I'm doing the conjunction of those two columns. Well, with AND, if either one is false, that AND statement is false. So I should write it right here. That's P and not Q. And lo and behold, in this case, we have a contradiction. That should make some sense. The idea that you have P and not P is kind of a crazy idea. That's like, I have one child and I don't have one child. That doesn't really make sense. Let's look at the second case, P or not P. So I'm going to put in not P, and then let me put the final one here, P or not P. So if P is true, not P is false. P is false, not P is true. Now for the disjunction, remember, that's only going to be false if they're both false. If one of them is true, it's true. Here we have a statement which is always true. That is a tautology. And think about what that says. It says we either have P or we don't have P. In that example I said a moment ago, either I do have a child or I don't have a child. That statement is always going to be true. I have a child or I do not have a child. That statement is always going to be true. That makes it a tautology. And that is the end of our video.